evening. This month, the ring planet Saturn is well seen. It's at opposition. It's in the constellation of Leo. It's high up after midnight and looking like a rather bright yellowish star. Well, the ring planet, but this year, the rings are edgewise on. That's the ring I made last time this happened. And therefore, Saturn looks rather unfamiliar. But to make up for that, we have the moons. And there are over 60 moons. With my telescope, I can see 9, but only one's really big, the rest are pretty small. Well, we're going to discuss 2 of these moons in particular. There's Enceladus, only about 300 miles across, and it's spouting ice geysers, and it simply shouldn't. And then there's Titan, bigger than our moon, with chemical lakes on its surface. Well, with me are 2 great friends of the sky at night, Professors Michele Dougherty and John Zarnecki. Welcome back.
Hello,
Thank
Patrick.
you, Patrick.
Now, the Cassini probe has been orbiting Saturn for some time, and it's been a great success.
It has indeed, Patrick. Cassini-Huygens is, of course, a joint mission from NASA and the European Space Agency. It was launched in '97, and it delivered the Huygens probe, which landed on Titan in 2005. Cassini itself has been orbiting for, 4 or 5 years
Yes.
now, observing Saturn, the rings, the magnetosphere, and, of course, the icy satellites.
And to me, you know, the most amazing one of all is the fountains of Enceladus, a tiny world only 300 miles across, the second of the major satellites out from Saturn.
That's right.
It should be a totally inert lump, and it isn't.
It should.
It's spouting ice geysers. Why?
We still don't know. We had a very distant flyby. We were about 1,800 kilometers away from Enceladus. And I must confess, I didn't look at our data for about a day because I didn't expect to see anything. And when we did, we saw this rather strange signature that seemed to imply that something was happening. There was something covering the surface of Enceladus.
And the discovery was due to you, wasn't it?
It was a remarkable detective story because, of course, you were looking to map the magnetic field.
That's right.
And you found that it was being deflected. There was something there that was pushing it away.
So what we did is we went to the Cassini project and said, we think we might be seeing an atmosphere at Enceladus. Can we go really close?
They must have thought you were mad.
They did.
Sure.
And after they'd said yes, for the couple of nights before the close flyby, I tossed and turned a lot because I had this vision of us flying by and not seeing anything at all. But what we saw were, as you said, Patrick, these geysers, these water vapor geysers emanating from the South Pole.
It must mean surely there's liquid underneath.
But why? I mean, Enceladus is small, its gravity is not very strong, and so the implication is if we're seeing these geysers all the time in this atmosphere at the South Pole, there's activity taking place all the time. And one of the really interesting things that we've observed is the amount of activity changes. When we fly by 1 month, there's a large amount of activity. A couple of months later, there's a much smaller amount of activity.
And that might be one of the keys to understanding what it is that's driving
so.
it. If we can make more observations, try to understand this variability. Is it related perhaps to something in the orbit? That would then imply perhaps that it is orbital heating, tidal friction of some sort that's driving it.
If it is, though, then why isn't something happening at Mimas? Because
Exactly.
Mimas is really close
The inner
by.
satellite,
Yeah.
smaller than Enceladus, closer in, and totally inert.
That's right.
And of course, Enceladus is sending out this material and feeding one of the rings, isn't it?
That's right. It's feeding the E-ring. There's this large diffuse ring which starts just inside the orbit of Enceladus, goes way out beyond the orbit of Titan. And so what Enceladus is doing is really generating the water vapor that's going to feeding the E-ring.
What about these tiger stripes?
These tiger stripes are just at the South Pole, and they're essentially large cracks in the icy surface. And
How deep?
the deepest one they've observed to date is about 300 meters. The thing that I find really fascinating is one of the vents through which the water vapor is coming out of is quite small. It's about 300 by 300 meters, so it's the size of a football stadium. And you've got maybe 7 or 8, maybe 12 of these vents that are actually generating this large water vapour plume.
Yes, I mean, I'm not sure, is that large or small? You know, I mean, we are dealing with an object that's fundamentally rather small.
I think it's small if you think about how much water vapour it's producing. It's producing a strange atmosphere that we were able to observe thousands of kilometres away. So I think it's quite small in the grand scheme
And
of
also,
things.
people, this amuses me, describe them sometimes as being warm or even hot.
That's right, yes.
You know, you have to put that into context, because I think the temperature measured with the infrared instrument on Cassini at these vents is something like minus 90 degrees centigrade.
That's
Which doesn't
right,
sound
yes.
too hot to me. But when you put that into context of the general surface temperature of Enceladus, which is something like minus 200
I think so,
degrees centigrade,
yes.
you can see why.
It's quite balmy in comparison.
Another thing bothers me too. We know this material is coming out now, and quite a lot of it. Been going on for a long, long time. Well, how much must there have been to start with?
Well, that's one of the questions that people are trying to understand is has it always been there? Is it something that changed recently in its past? But since the E-ring, we've known that the E-ring has been there for many, many years now. The implication is that Enceladus has been feeding the E-ring for a long time in the past, and it will continue to do so.
I mean, it might be possible, might it not, that this is, if you like, a special time in the history of Enceladus, the history of the Saturnian system, but then we're not comfortable really
Especially
with...
for our benefit.
Well, but when the Voyager spacecraft flew by in the late 70s, they saw this very young surface at Enceladus. And if it was young then, the implication was that it had been resurfaced some time before that. So
What about the rest of the surface, away from the pole? Craters, ridges, hills?
there are all of those. There are more craters away from the South Pole, so the implication is that a lot of the resurfacing is taking place
But
at the
still
South Pole.
relatively few,
But still,
isn't that
yes,
right?
especially in comparison to Mimas, which is really very heavily covered in craters.
Indeed.
Also, one of the other really interesting things is that it's now driving our focus for what we want to do in the future. We want to send a new mission to Titan and Enceladus so we can really better understand the processes that are going on.
And of course, I mean, I don't want to give you the wrong idea, but we do now seem to have, at Enceladus, we have some source of energy.
We do.
We have perhaps, or very likely, liquid water, and we have organic molecules. You know, these are three of the basic building blocks for life. Now, I'm not suggesting for a moment that we have, you know...
little green men running
or
around
even
on the
bugs.
surface.
However, I think it increasingly shows us that the solar system is far more exotic
Yes,
than we ever
it
thought,
is.
and there are far more potential habitats where biological activity perhaps could develop.
The fountains there are the weirdest things we've found yet. They just should not be there, and they are. But don't forget the other satellites. There is Titan, bigger than our moon, actually bigger than Mercury, with chemical lakes.
Finally, we now know that there is liquid on the surface. I think it was the visual imaging mass spectrometer that has now definitively shown that there is liquid on the surface.
Methane or what?
It's mainly ethane. There's some methane and there are some other hydrocarbons as well. It's in a lake called Lake Ontario Lacus.
How big is it?
It's about 200,000 kilometres. And in fact, I think it's slightly smaller than Lake Ontario, which is what it was named after. And I think one of the really interesting features about this particular lake is from the observations, it looks as though the ethane and methane is evaporating over time. There's a dark lake shore that is seen as well.
They don't cover the whole surface.
No, they don't. The lakes seem to be focused closer to the poles. So we've seen lakes at both the South and the North Pole. The equatorial regions are mainly...
They're drier, aren't they?
dunes, I think, yes.
Yes, these strange dune features.
Well, we've seen evaporation going on there, so there must be replenishment in the form of methane rain.
Yes, there must be methane rain of some kind, and it's very clear that there are weather systems taking place at the poles, particularly at the South Pole.
Yes, I mean, we saw that fairly complex
Yes.
cloud system, which we saw changing. And now, of course, the imaging is showing that the lakes appear to be changing in their structure. Either,
That's
I'm
right.
not sure if they're filling up or evaporating. So clearly, methane is playing a role akin to water on the Earth. There is a cycle,
There is a methane cycle
of precipitation and then evaporation.
And Huygens, the little lander carried by Cassini, they were touched down gently on the surface and sent back amazing pictures.
It did.
What were those pictures like?
I remember when I first saw them, they looked remarkably Earth-like. Pebbles, smooth edges, the result of liquid flowing. But of course the pebbles are not made of stony material, because we must remember Titan is fundamentally an icy body, so these were pebbles made of ice. We saw river channels carved on icy hillsides.
And let's come on now to one other point. We know there are more missions planned, and the question is, Jupiter first or Saturn first? And there were pros and cons on both sides. And we now know the decision being made is going to be Jupiter first, mainly because of the strange satellite Europa, underground ocean, and of course the big satellite Ganymede. And Saturn must come later. Are you happy about that?
I'm torn, partly because I was involved in putting the plans together for both of them. I think they both have pluses. I'm really excited about going back to both Europa and Ganymede because they both have internal oceans. We want to try and understand them. But the more and more we learn about Titan and Enceladus, the more I want to go back there. So I want to do both. I don't really mind which order I do it in.
Well, I have to say, Patrick, from my point of view, it depends on whether my brain or my heart answers that question. I mean, my heart, of course, belongs to Titan, and I feel I know it so well that I'd like to go there tomorrow.
Well, Titan will come later. Michele, John, thank you very much.
Thank you.
Thanks, Patrick.
Now, our own moon's very much in the news. There are several satellites going round, one Chinese, one Japanese, one Indian, and a new American satellite due for launch in the near future. And there's been a major conference about it at Milton Keynes. Very sadly, I couldn't get there. But Chris did, and this is his report.
It may be a wintry, cold and bleak day in Milton Keynes, but the minds of the scientists who've travelled to the Open University are somewhere even less hospitable, the surface of the moon. The moon is our constant companion, and it would be easy to take it for granted. But its familiar face holds many secrets, secrets that have launched a new age of lunar exploration.
6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
This July will be the 40th anniversary of Neil Armstrong's first small step onto the lunar surface.
That's one small step for man, one giant leap for mankind.
Each of the 6 missions which landed on the moon brought back samples which have been pored over by scientists ever since. Dr. Katie Joy studies the moon in order to try and piece together its dramatic history.
The one we believe most is probably that the moon formed in a large impact event. So a Mars-sized body, which scientists have called Theia, crashed into the early Earth, and this probably occurred maybe 50, 60 million years after the start of the solar system. And so from this giant impact, we had a lot of material orbiting around the early Earth, which coalesced together to form the moon. So we're testing this theory by studying samples that were brought back by the Apollo astronauts, and by targeting places on the moon in the future, we'd like to go back and get more samples to test this theory.
So why hasn't Apollo answered all these questions? After all, we've had men standing on the moon and touching the surface.
The science that's come out of Apollo, I don't think is appreciated by just, by many people.
It wasn't just putting flags on the surface.
No, it wasn't, absolutely not. No, we have the rocks, we have in situ seismic measurements that were made, we can study the lunar environment. However, it only visited near-side equatorial latitudes, so very limited spatial coverage. So, for example, we have no rocks from the far side of the moon from known locations that were brought back. And the places that we went to on the near side of the moon are actually very strange geochemically. So they're associated with a very a hotspot of thorium, which is a heat-producing element.
Okay.
And the fact that we went there and all of our data is kind of characterised by this signature suggests we need to go back to different areas. We need to sample a greater range of diversity of rocks.
For the first time in almost 40 years, there are 3 separate missions active at the moon. There's the Chinese Chang'e 1, the Indian Chandrayaan 1, and the Japanese with their Selene probe.
Main engine ignition.
SLBA take off. Lift off.
SLBA ignition and liftoff.
The Japanese mission was the first to be launched in September 2008. The cameras on board Selene have taken these magnificent movies called Earthrise and Earthset. The Japanese have also been examining the Apollo landing sites. Here's Apollo 17's in the Taurus Littrow Valley, as seen from Selene. Here it is back in 1972, taken by one of the Apollo 17 astronauts. Very little changes on the moon. This is the Hadley Rill, where Apollo 15 landed. In this red circle you can just about see the blast zone, left behind after the lunar module took off from the surface.
I conduct a similar analysis of all of the lunar surface. We select 70 craters and
the Japanese team are here at the Lunar Conference to present some of their early findings.
At first, I was interested in the Earth's crust, and but because Earth are still living planet, therefore to study the Moon, we can more understand the very early stage of the cluster formation. That's why I am very interested in the lunar crust.
This map of the moon has been released by the team behind the Chinese Chang'e 1 probe.
3, 2, 1, 0, +1.
Yes.
The newest mission at the moon is the Indian satellite Chandrayaan. On board is a British instrument, KIX. It looks at the moon in X-rays, telling us what it's made of.
KIX is an X-ray spectrometer. So it looks at the moon in X-rays. The sun shines on the moon in X-rays, rather sporadically at the minute. And when the sun shines on the moon in X-rays, the moon glows in X-rays. It glows in X-ray colours. It glows in the magnesium colour, the silicon colour, the aluminium colour.
So in other words, that tells us what the moon's made of?
Exactly so. And what we're able to do, therefore, is say what's the whole moon made of, which is something that hasn't really been done well yet. Certainly not for the rock-forming elements, which is what the X-ray technique is sensitive to. And so, obviously, the question is, did the Earth and the Moon come from the same place? And in order to answer that, you need to ask yourself what the whole Moon is made of. That's what we're about.
We had the old idea that the Moon and the Earth were formed next to each other, and then the new theory from the Apollo era that something hit the Earth and the leftover material created the Moon.
That's the best theory on the block. It's the only theory on the block. But if you remember when the Apollo astronauts brought back their samples from the near side and the equator and flat bits, they, when they first looked at those, what amazed people was how like Earth mantle material, Moon material was. And so that theory was created to explain that similarity.
As you say, they only looked at a small part of the Moon, the boring bits, in fact.
And moreover, the more they've looked in detail with more and more modern techniques, they've found that although the bulk composition is the same, the rare elements in it, some of the rare Earths, are not compatible with Earth observation. So more and more, this theory which was supposed to explain that the Moon had come from the Earth actually says, no, the Moon came from the impactor. And in order to really answer that question, because as you say, what they brought back was very atypical lunar material, what we have to do is look at the composition of the whole Moon, and that's how we're going to get to the bottom of that mystery.
One of the most intriguing parts of the lunar surface is the South Pole, where some scientists believe there might be large deposits of frozen water hidden beneath the surface. This April, the Americans are going back to the Moon. They're sending a mapping mission called Lunar Reconnaissance Orbiter, which will detect boulders as small as a microwave oven. Tagging alongside is another mission, L-Cross. The upper stage of the rocket that takes them there will collide with a crater near the Moon's south pole. The spacecraft will follow just a few minutes behind, looking for evidence of water, which some believe will be thrown up by the explosion. If there is water there, then NASA plans to use it for future manned missions. In the more hospitable Open University canteen, I sat down with NASA's Greg Smith to discuss the challenges that a lunar colony might face.
There's certainly a large amount of technology development. One of the goals about having people on the moon in the first place is learning to live off the land. We at NASA, I think internationally as well, have the acronym ISRU, which means In Situ Resource Utilization.
Don't take it with you if you can make the most of it while you're there.
Exactly. So we need water for many different processes for humans on the moon, and if we can get it there, so much the better in terms of resupply. There's a lot of other questions, though, that we need to answer, some of which our institute is going to start helping with. So, for instance, dust. Lunar dust has been known about, of course, for quite a number of years.
The Apollo astronauts complained about it, for starters.
Exactly, and it has some very special properties that are difficult to replicate on the Earth in terms of its chemical reactivity, in terms of how sharp the dust grains are. Dust here gets weathered, for obvious reasons, from the air circulation, from dust grains constantly hitting each other. That doesn't happen on the moon. And so it could have some special difficult qualities to deal with when you're designing machinery to last for years and whatnot. And so it's very important to answer these kinds of questions, as well as life existing, for long periods of time in 1/6 gravity, high radiation, all of that.
Getting man back on the moon remains as distant a dream today as it has done since the 1970s.
I'm looking for a place away from craters and rocks. That's why I didn't land up there.
While we wait, though, we can already enjoy the results from the largest armada of spacecraft ever to visit the moon.
Right away, Houston. Vector good.
Well, the moon's always there, of course, and by in particular subjects, but there's plenty else to see in the sky. So let's go into my garden and join Pete Lawrence.
One of the objects which is visible in the March sky is Comet Lulin. And Comet Lulin, for once, was a comet that actually did what it was supposed to do. It reached naked eye brightness at the back end of February. In fact, it got slightly brighter than that and was about as bright as the fainter stars in the Pleiades or Seven Sisters cluster. You can still see it at the moment if you missed it in February, but to do this, we've got to find some pointers in the night sky. One of these is Regulus in the constellation of Leo the Lion. Now, to find Regulus, we can use one of our old friends, the plough, or as I prefer to call it, the saucepan. If you locate the two stars which are closest to the handle of the saucepan, and then point them down, extend them down towards the horizon, and eventually they come to a bright star, which is Regulus. You know if you've got Regulus because there is a backward question mark of stars just above it, called the sickle, and that's supposed to represent the head of Leo. So that's Regulus. Remember where that star is. Now we have to find some stars a bit further to the west, and these are called Castor and Pollux, and they're the two heavenly twins of Gemini. Now, to do this, we can use another old friend, which is Orion the Hunter. Now, Orion is very prominent in our skies at the moment. 7 very distinctive bright stars. But if we pick out the 2 brightest, the one in the bottom right, which is called Rigel, and the one in the upper left, which is called Betelgeuse, and extend a line from Rigel through Betelgeuse for about 2 times the distance again, and you come to the 2 stars, Castor and Pollux. Castor is the one at the top, Pollux is the one below it. Okay, once we've got that, we can draw a line between Castor and Regulus, find the midpoint of that line, and then just below that region there is a lovely open cluster of stars which is known as the Beehive cluster. Now, this is bright enough to actually be able to be seen with just the naked eye, but a pair of binoculars will pick it out very well indeed. So if you can find the Beehive cluster on the night of the 5th and 6th of March, so that's the evening of the 5th into the morning of the 6th, use a pair of binoculars, have a look at the Beehive cluster, place the cluster at the top of the field of view, and Comet Lulin should be in the lower part of the field. What does it look like? Well, it's just a fuzzy blob, possibly with a hint of tail either side of it. You can't see much in the way of colour, but if you take a long exposure photograph of Comet Lulin, it comes out vividly green, quite an intense green in fact. Now, throughout March, the comet dims. It dims from just under naked eye visibility at the start to just about the threshold of a pair of binoculars at the end. So it's still very possible to see it as it heads in towards Gemini. Well, one thing you definitely don't need a pair of binoculars to see is the planet Venus. And if you've been outside over the last couple of months or so, just after sunset, looked up high in the southwest, there it has been as a brilliant beacon in the twilight sky. But it's not going to be there for much longer. Things are changing rapidly throughout March because Venus will get lower and lower and lower and then eventually disappear altogether from the evening sky and reappear in the morning sky. So now is a really good time to get out and have a look at this amazing planet. If you have a telescope and you can train it on Venus, say throughout the first couple of weeks of March, you should be able to see that the planet is showing a very distinctive crescent phase. It's a very thin, slender crescent at the moment and actually quite big. In fact, personally, I think it's one of the most beautiful sights in the entire night sky. The other major planet on view at the moment is Saturn. And Saturn's pretty easy to find, being in Leo the Lion. The best way to describe where it is to locate Regulus, the position which I gave earlier, and then look to the left and below that position. If you see a bright yellowish star, that's Saturn. Now, Saturn is an interesting planet to look at through a telescope, but at the moment it's tilted almost edge on to us, so its rings appear very thin. But the orbits of its major moons are also tilted fairly edge on to us, and this can give rise to some incredibly interesting effects. One of these occurs when a moon moves across the face of Saturn, dragging its shadow behind it. Now, I'm quite excited because on the morning of the 13th of March, at about 2:30 in the morning, there's going to be not one, but 4 satellites doing exactly this. Now, if you have a largish telescope, say a 12-inch or greater, and you look at Saturn, you should be able to see these 4 tiny dots of the shadows of these satellites moving across the face of Saturn. You might even be able to see the satellites themselves. But I really hope that the skies are clear at this time and you'll be outside joining me watching this rather amazing event.
Well, there's plenty to see. On to our news notes now, and Chris. Chris, one thing intrigues me particularly, the discovery of a planet not much bigger than the Earth, although not the kind of place where we could live.
Yes, this is the smallest planet yet, discovered by the mainly French satellite Corot around a star just over 450 light-years away. It was caught moving in front of its star as we see it. It orbits once every 20 hours, so far inside the orbit of Mercury if it were in our solar system. That means that it must be a very hot world indeed. It's small enough to be a rocky planet, but the temperature is about 1,000 degrees centigrade. So the surface is either superheated water or something like that, or just lava.
I don't think we'll go there. And one lovely picture, we must show, I think, the Eta Carini Nebula.
Yes, well, this is the whole Carina Nebula. It's a beautiful star-forming region, 4 times the size of the more familiar and slightly nearer Orion Nebula, imaged here by the Very Large Telescope in Chile. And it's an image like this that gives you a sense of how beautiful and complex these star-forming regions are. There's a huge amount going on, and actually it's just a work of art as well. It's a beautiful image.
Of course, Eta Carini itself, a star 5 million times more luminous than the Sun at least, and our next supernova candidate.
Yes, one of the most massive and most luminous stars known, reaching the end of its life for sure. Who knows when it will go bang, but at least it's far enough away that we can watch the show without it doing us any damage.
Not from here, it's too far south.
Yes, that's why you put the telescopes in Chile.
Chris, thank you very much. Next month, we're going to talk about the Herschel Infrared Telescope, about to be launched into space. An exciting mission. And a special report from Chris, who went over to Holland and was able to see the telescope before launch. So until then, good night.
Coming up, 3 Venuses from the 50s and all with the same surname, the Beverly Sisters.